Okay, welcome. This is a session on concepts of engineering and quality management. Specifically, we're going to be talking about planning production activity and managing production operations. Good evening. My name is Dr. John Jactiani. I'm pleased to be here with you for the next 30 to 40 minutes. I will have your attention and request your attention on discussing this important topic. So, when we talk about managing technology, we have already in previous sessions reviewed research design. We are now going to be talking about planning production and then managing production. And later in subsequent sections, we're going to be talking about marketing and project management. I want to focus here specifically on the role of the engineer and the engineering manager, particularly in the production process, okay? I want to talk about planning as it relates to manufacturing and specifically manufacturing facility design. I want to talk about production planning tools. And last but not least, I want to focus on the difference between planning and control, right? Two different things. Sometimes we use them synonymously and interchangeably, but we want to talk about differences. There are many positions, engineering positions that you might see job applications for, requirements, needs. These haven't changed in a while. They still continue to be pretty strong and prevalent in the marketplace. We have maintenance engineer, industrial engineer, process engineer, quality engineer, test engineer, safety engineer, manufacturing engineer, environmental engineer. These are very closely related to the EOM field as well as IE. Obviously, we know our electrical engineering, mechanical, computer engineering, network engineering. There's many other engineering disciplines. But when we talk about production and production optimization, production planning, these are the types of engineers that find themselves jobs, or these are the job needs, role requirements, if you will. When we're talking about production planning facilities, people are most concerned about the area where the facility is located, the community, the actual selection of the site, and common errors in production planning processes and facility management. Can we just take a moment to talk about what's important when we select an area for our production facility? We want to know, what markets are we serving? Where are our markets? If our markets are very distant, it's going to be hard to connect. Also, where are the materials coming from? Even more important than the market, right? Where are the materials coming from? If the site is very difficult to reach, maybe it takes a long time, maybe there's very poor infrastructure, it might be rural, that might impact supplies. Labor, right? Are we able to find qualified people? Those engineering roles that I talked about, do they exist in the southern part of North Dakota, right? Southern part of North Dakota, I love that. Location of other plants, right? Where am I going to have to transport this material to? So out of this, I think the location of where my materials are coming from and my labor supply is very important, right? I can't get a lot of people to move in remote areas of the country or the world. I may not have the right labor pool, right? Of course, that's about to change with this pandemic situation that we have, because now many people are stretching the envelope and being able to work remotely. Many more people are going to work remotely as a result of this crisis, right? We are learning. I mean, we're talking about education, we're talking about schools, low elementary as well as higher education, we're talking about government workers, we're talking about hospitals, telemedicine, we're talking about doctors working remotely, we're talking about so many different things, technologists, engineers working remotely. So labor supply is about to get more facilitated with this, because we can access labor in certain cases remotely, right? Not always, but maybe the planning can be done off-site, right? And so on. Community depends on the culture. Where are we based? What are the regulations? Maybe there's some tax implications. Maybe there's some financial incentives or disincentives, right? And maybe there's some sort of physical preference. So, you know, there is an importance of how this sort of works, right? The actual site has very specific attributes that need to be considered. Obviously, the size, the location. Do we have access to utilities? You know, all the services. Believe it or not, Wi-Fi is not, internet cabling isn't run the same way. Fiber optics aren't run the same way even in the United States. So there are certain areas where you can have access to cheap land, but you may not get reliable internet connectivity, or you might have to use data lines. That would not be optimal for a manufacturing facility that's trying to communicate with the head office or with customer bases or so on. And a large factor here is land costs, right? Facilities are normally not built in New York City or in downtown locations, right? They are generally remote because they use up a lot of land, but they have to worry about waste disposal and internet connectivity and things of that nature if you go remote. So it's a trade-off. There's a lot of errors, right? Facilities move all the time because of poor planning or a change in the environment, miscalculated costs, inadequate labor supply, taxations, rules changing over time. There's a lot of discontinuity with this, and people have to reverse decision, and it hits the company's bottom line when every time you have to make a change to a facility or move a facility, God forbid. You know, this is many companies don't have the resources to do this more than once. So it's very important that people plan. And how do you plan? Well, you start with demographic information. Census.gov gives you, for example, in the United States, stats around where the populations are, where the labor pool is, you know, where high earners live, where there's saturation, etc. A lot of research can be done and is done that starts with the most basic things and goes to more advanced inputs. When we talk about planning and planning the layout, we need to understand how the work is going to be done. We need to actually start to dig into the realities of the business. What are the processes? What are the work centers going to look like? What are the departments structures going to look like? What machines and other assets do we need? What are some of the inputs and outputs, right, from each process? And what are then the transportation needs to facilitate that in their information transfer or materials transfer, right? So this goes into the more physical and technical infrastructure layout, right? You want to minimize the costs, obviously, how many times you move things around. You want to make sure safety is maintained, efficiency is maintained, people aren't overly concerned. Like, for example, we did an addition on the local hospital here, not we, meaning the town did. The hospital's poorly designed because the patients are on one end of the hospital, the doctors are located on the other end. They thought they were doing a smart thing, but the doctors visit the patients, right? And so the doctors are constantly wasting a lot of time going back and forth, and now they have to redesign the hospital here locally in my town. That's an example of a very basic faux-pas, right? Pretty bad, right? Pretty bad. But the stuff happens, and right now, until they fix it, the morale is reduced, right? I'm sure there's a bunch of doctors who are kind of lazy, kind of not, are too busy. They may not be taking trips to see their patients in their rooms as often because they have to do a 15-minute walk from one end of the hospital to the other. So it really does adversely impact morale if it's not done correctly. So companies and facilities management have to keep morale in mind as they're doing, because the workers have to deal with it. Everybody has to, it gets impacted. So communication is important, coordination, flexibility. As you can see how what I have on this slide, these 4 points, project planning becomes increasingly important, right? Running a facilities project is huge, and you need those project planning techniques that we talked about earlier this evening that we'll be talking about more in the next session as well. But I'm teeing you up for the fact that there's a strong need in production management, production planning for project planning. Project planning is a universal discipline, right? Universal set of skills that can be applied. What kind of tools do we need to do this kind of planning? Well, we need financial tools, right? Financial tools are where people start, right? What are the efficiencies? What metrics are we trying to meet? If we are going to incur costs, what are the break-even aspects of those costs? When do we actually start seeing results from every cost that we incur as part of this planning, as part of the build-out? Are we taking into concern the learning curves? If things change and we have a new facility, what is it going to take time? How long is it going to take? And what is it going to take to train people to work efficiently in that new environment, right? There's a whole study on learning curve theory that's important. Break-even charts are driven by 2 things, right? You might have seen this before, but we've got fixed costs, variable costs. Fixed costs are independent of how much you produce. They're your, desk, furniture, machines, right? Those are fixed. Even if you produce 1 unit or you produce more, you're likely going to have fixed costs just to have the operation going. Variable costs vary directly with the level of production, right? So variables costs go up when production goes up, right? Materials planning, manufacturing planning, enterprise resource planning. There's various aspects of planning and controlling these projects. So resource, and everybody kind of knows intrinsically the difference between resource and requirements, right? You've got requirements for materials. How do you plan that out? How do you make sure materials come in on time? How much storage do you need? Inventory do you need for different types of material? This goes into the facility. How much of a warehouse do you need depends on how difficult it is to get those materials based on how much you're projecting to produce, right? Storage has costs. You can't store things indefinitely, right? Enterprise resource planning is all of the resources that are involved in making the business a profitable business. For example, you have human resources, you have system resources, you have processes, you have data, right? How do you manage data? That's part of enterprise planning, right? Enterprise resource planning. So when we talk about ERP, this is near to my heart because I did a lot of ERP systems implementations in my career in industry, right? Implementing a workflow system, right? Implementing Workday, for example. The university uses Workday. That's a whole ERP system where finance, accounting, technology, faculty, administration all come in and have a part in that system so that the work gets done, and it's facilitated by using a certain paradigm. Salesforce.com touts being an ERP system. Now I think Salesforce.com is largely a sales automation system, but they have so many hooks into different aspects that run the business. So Salesforce.com is a cloud-based platform that's an ERP planning software, and it has every component of the business. It's got finance can manage itself, accounting can manage itself, account receivable can manage itself, you've got HR that can manage itself, you've got procurement and facility management that can be done in Salesforce, you got sales automation, of course, you got call center and service every function of the enterprise that involves people and technology can be put together in a seamless platform. So there's automatic transfer of work, automatic movement of information, people getting the information at the right time, the operational systems, the analytical systems all working together. It's a beautiful thing. And I expect a lot of you people and students listening to this are going to end up having careers either now or later in this area. So requirements, resource, and enterprise resource planning are key that surround manufacturing and are absolutely needed to control these processes. And then, of course, in manufacturing system, the last thing I want to say here is you've got lean manufacturing, which takes away wastage, right? Takes away dead processes, right? We talked about value engineering, takes away inefficiencies in making the manufacturing process more lean. You might have heard Lean Six Sigma. You know, these are all improvement methodologies or way to look at and streamline manufacturing. And many jobs are left to be had in here, or this is a growing area for production planning and management. Okay, so I'm going to pause there for a second and take some questions before continuing to the next topic. So next we want to talk about the management of the production process. We just finished talking about the planning, facility planning, materials planning, labor planning, and related areas. Now we're going to talk about the actual process itself. So this is the best quote, right, that I can see we can start with. If you always do what you always did, you will always get what you always got. That means no change means no change in output, right? I would even go further, is that sometimes if you make no change, you will see degradation in output because change is constant, right? You have to change. Even to maintain, you have to change. So the real story is even worse than this quote, but the quote is basically trying to say you have to make changes if you want to improve output, efficiency, and so on. We're going to define what quality means. Quality revolution, right? Started by the Kaizen movement in Toyota years and decades ago. We have some quality tools that we can review and as an overview. And again, much of this is in the quality improvement detailed class that you'll have an opportunity to take in the future, hopefully here at the university. So the major focus of production is on efficiency and effectiveness. That's where management is always laser focused on, right? They're laser focused on improving metrics and getting more output, generating more developing more widgets. And they have lots of process engineers always optimizing, right? And making sure that the process is as effective and streamlined as possible. Not everybody does a great job at this, by the way, but that is the hope. And that is the premise that businesses operate under, because they've got to operate with profitability in mind. And profitability is directly related to reduction in cost. And if you're inefficient, you're going to, by default, have higher costs. So the goal of a company, by nature, is to focus on this aspect of the production and operations. But to do this, you have to be analytical. Engineers have to be analytical. They have to be measurement oriented. They have to be results oriented, okay? And I say that, and you might be hearing me and say, okay, well, that's understandable, right? But it's hard to achieve. Not everybody's mind and not everybody's work habits are trained this way. This is a training and a skill development issue, okay? It's not so easy to make it happen by just saying it, all right? And you have to be actually trained in doing measurements and making sure you're measuring the right things. So if you measure the wrong things, you're going to have erroneous results and you're going to be focusing on the wrong things, right? There are some traditional quality measurement tools like process control charts, like inspection and sampling. There's something called the Taguchi method that you might have read about, right? Inspection and sampling is easy, right? You go, you put glasses on, you put a binocular on, you put a microscope, under the microscope sort of analysis, you walk around the plant and you sample. You sample defects, you sample processes, you see how things are running, and you fix things. Obviously, you can't get to everything, right? It's got limitations, but it's easy to do and it's intuitive. Quality is trickier, right? We always want high quality products, but we don't even know what quality means. We have to define quality. I hate when people talk about quality. I can't stand it. When people talk about quality and they can't define what high quality means for their particular product, for their particular process, even for their lives. We want high quality lives, right? How do we know if we have a high quality life? Just because we feel better one day and we don't feel good the next day? Not quite. How do you measure quality? Maybe some of us measure quality by financial rewards. Maybe some of us measure quality by the relationships that we have and the quality of the relationships. Maybe somebody measure quality by the kind of food we eat every day. That might be me, by the way. But, right? So it just depends, right? So you have to define quality. And once you define quality, you have to work towards having plans to meet the requirements, meet the needs, and meet the desires, right? Meet what the customer wants. We're very customer focused, right? So who defines quality? Customer, right? Does the customer always want to pay for 100% quality on a production process? No. They might be okay with 90%, 80% quality, depending what it is. If it's a suture or a needle for or a artificial heart valve or a cardiac situation, surgical apparatus, obviously they want 100% or close to 100% quality, right? Health depends on it. But if it's a belt on an alternator in my car, and if it fails 10% of the time, but it's good 90% of the time, I might be okay, because I might not want to pay the additional 500% premium to get it close to 100%. You know, just depends. Brakes, no, I don't want to cut short on my brakes, right? I want high quality brakes. I want my car to be able to stop. But if the speedometer is not of the highest quality, it breaks down once every 100,000 miles, it's all right. Yeah, I can live with it. So quality frameworks, modern day quality frameworks are built on a very strong premise that quality becomes every person's responsibility to achieve. And it starts with customer expectations, right? It's so important. TQM, Total Quality Management, have a lot of, there's a whole class on this. I got a whole series of training that I do around this. And it starts with various notable researchers and experts. Deming, Duran, Crosby. Okay, these are fathers of TQM, if you will, right? They have a lot to say about it. The Baldrige Award is a famous corporate award, like a industry award that is awarded for quality. And I had the great pleasure of working for IBM back in the early 90s, and we applied and won the Baldrige Award in our division. And it was a whole process that took almost 3 years to prepare. So there are internationally recognized committees on evaluating companies' processes and mindsets, really, and way of doing business, whether it adheres to quality standards. It's not just about creating the best products, it's about having a commitment to the entire company, to your customers, to your ecosystem, to the brand equity that you build on high quality. That's why we can associate quality with many things, right? Like we, buy Nike and we know we get good shoes, high quality shoes from Nike, for example, for athletic wear, right? Or we buy a Honda car, high quality automobiles, right? For instance, some of you may agree, may not agree, but I think they're high quality. I've owned 7 Hondas. I had to throw each one out before it even died. Okay, I swear by Honda quality. I get sick of the Honda cars before they actually have to be replaced. That's how good they are. They're not the fanciest automobiles. I mean, I'm sure a BMW would be a lot nicer, maybe, but I don't think so. I like my Hondas because I know that I can drive them 200,000, 300,000, 400,000 miles, and it'll get me places, and it's easy to repair, and it's just, there's nothing to repair. It hardly breaks down. Knock on wood, of course, right? So quality is synonymous with a lot of companies' name because they invest in those processes over their existence, basically. It's not just a one-time thing, it's a way of life for many of these companies, right? So there's the plan, do, check, and act PDCA cycle that is very famous, right? In this TQM area. And this is the process for continuous improvement. We basically plan, then we do, then we make sure that we did things correctly, we make adjustments, and we act on those adjustments, and we feed that into the next planning cycle. So companies that use the PDCA are likely to be on top of their upper echelon for quality processing. Deming created a 14-point checklist. Okay, I've summarized it here. It's a little verbose, but it's important, right? He talks about a 14-step process to ensure quality. Start by having a purpose, a consistency, a constancy, a uniform purpose that encourages everyone to align. Secondly, we want to adopt that philosophy, spread it, have a philosophy of defect prevention, right? End the dependence on mass producing or mass inspecting. Can't have inspect and sample because it doesn't work, right? It only works for a limited set of process improvements. Focusing on purchasing solely on price shouldn't be there. We have to talk about quality versus price. Improving constantly. Using modern training methods, recognizing that training and methods change, philosophy changes, organizations grow, goals change. We want to align, constantly align, and we want to couple it with number 7, leadership, right? Supervisors must become coaches. They must become the example, right? You have to eliminate fear so people do a good job. Fear impedes performance. Remove the fear from an organization. Watch the organization flourish. That was what Deming focused on. Eliminate numerical goals. Don't just focus on new numbers or words, fancy words. Let's show quality improvement in every step of the way. We need to generate better products this year than we did last year, and we need to generate better product next year than we did this year, period. It's a commitment, right? It's a commitment. Eliminate standards that don't make any sense, quotas, right? Yes, we need financial goals, but we need to make sure that quality isn't compromised. Let's remove barriers. Let's create pride in workmanship. Let's create, let's emphasize self-reward, recognition for quality. Commit to education. Commit to training. When people make mistakes, you pick them up, you train them, they do better next time. And create an organization structure that has quality as primary paramount, right? Adopt the PDCA cycle, right? From the first process to the last. The Baldrige Award has a criteria. We talked about this earlier about the Baldrige Award. They look for leadership, strong leadership, strategic planning, market focus, customer focus, measurement. You don't measure your processes, you don't even qualify. Focusing on people, focusing on the human aspects, not just the technology aspects. Managing process, having somebody looking after, departments, groups looking after processes, right? And then correlating all of these to business results and seeing if they're driving business results. If they're not driving business results, having a process to change so that business results are driven by these quality processes. Quality spans across the board. It's not just production, but it's also how the business is conducted. How do you serve your customers? How do you educate the market? How do you message? How do you communicate to internal and external stakeholders, right? All of these have to be high quality, not just the production process. For instance, we have the ISO 9000 standard for engineering. It requires an organization to create processes in all functional areas that focus on customer needs. And each process has to validate their own requirement of quality, not just have a uniform quality. The ISO standard was developed and it's heavily used, right, in technology-based companies. It's developed in 1947, and then it included businesses, business standards back in the 80s with the ISO 9000, and then in the 90s, it included quality aspects for environment management, and that's the ISO 14,000 framework. Quality Reward focuses on results and continuous improvement. But ISO helps determine what's needed to maintain that improvement, maintain a quality conformance system. So that many companies use both, right? They use both criteria to make sure that they're covered and they're focusing on the right thing. Now, I'll tell you, look, the crisis that we're having right now, right? Forget quality. We have a desperate situation, right? I don't think they need high quality ventilators right now. They just need ventilators. They need, hospitals are looking for subpar stuff right now just to help people out, right? And that's okay because it's a function of the environment. Is that always going to be the case? Absolutely not. You can better believe it's not going to be the case. Once we get over this pandemic, once we get over the crisis, then we go into normal quality mindset. That does, if external circumstances necessitate survival, we have to do what we have to do. Okay? Of course, we don't throw quality away completely, but we do relax some of the stringent requirements in favor of saving lives or protecting people, protecting our customers, which are people who are affected by this virus, right? But listen, quality is a commitment. It starts with management commitment. It focuses on the customer, not the individual. It's the customer, right? Customer is always right. We've always heard that. Yes, we've got to focus on the customer, start there, and then start to layer processes around it, not in spite of it. A continuous improvement mindset, Kaizen, from my Six Sigma class. If you take the Lean class, you'll see quality improvement, Kaizen processes, and Lean Six Sigma, etc. We want to make sure the entire workforce is involved. It's not just a quality department that looks after it. It's a mindset. It's a way of doing business. It's a way of conducting yourself. And it is, lastly but not least, measurement focus, as I mentioned. Customers, remember, when we talk about customers, we internal, external customers, right? You all are my customers. You heard me say that on the first day of class. And your feedback helps me improve the quality. If you don't give me feedback, there's a good chance that the quality degrades because I'm making assumptions on what I think you need. At the same time, the reverse is true, right? I have to give you quality assessments on your work. You're submitting things, I'm giving you feedback, and if I don't do a good job with that, then you may not be getting the most out of the course. So I got to do a good job with that. Every time you get less than 100 from me, you will get feedback. That's my commitment. You always get feedback, right? And that's how I wasn't always like that. Sometimes I used to just give people like a 90, and I think it's obvious why you got a 90. But if you don't get 100 from me, you'll always have something now to show you why you didn't get 100. Because I'm expecting everybody to get 100. Because I'm expecting high quality across the board. And it's my job. If you're a little less every now and then, I'll give you the tips. You follow the tip next time, watch your score improve, right? Continuous improvement is built in to the very nature of what I do. And that's what I'm trying to talk about here, right? No, it's largely a mindset thing, right? Many tools, many tools. Your book covers some of these. You've seen a lot of this. Affinity diagrams, flow charts, Pareto charts, run charts, fishbone. What's a fishbone? Fishbone, anybody know what a fishbone is? Don't answer that. I'll answer it for you. You like how I ask the question? I don't let you guys answer it. I'm recording, remember? So I want to finish this, and then you guys can ask questions just in a few minutes. But I forget that I'm recording, so I have to, I'm tempted to ask you. So a fishbone is basically looks like a fish skeleton, and it has the key problem, and then a categorization of why those problems and quality issues are happening. And you can see pretty much a spine bone or center bone of the fish, and then different spokes coming out that look like a side view of a fish skeleton, right? You might have seen that. And it's a way to basically organize different things, different quality issues that might come up with the production process, or a quality issue that might come up with a process improvement situation. And it's just a way to visually see things. It's very effective, right? And we have a lot of these these are just a sampling of techniques that help with understanding quality issues and digging to the root causes. Work sampling, as I mentioned, okay, is still active, but it is sporadic. You can't possibly sample every piece of process or every component of a process by just examining it, right? It'd be very costly and very prone to human error. So you have to rely on automated measurements. When we talk about work measurements, we talk about standards as a baseline. Then we talk about what the normal, under normal variation, standard deviation, what might that normal time be? What's the correct pace of a process? And then what are the actual allowance, the actual times and the different allowances that maybe provide that deviation? And finally, maintaining facilities require a lot of ad hoc processes that sometimes are very hard to optimize. For example, you don't know, I have a boiler, right? And I have a new boiler in my house. It provides me heat. It's got probably 100 to 200 parts. And I really don't know what the quality of each of those parts are. I might not even know how to take care of each of those parts really well. They tell me I got to have once a year servicing. I schedule once a year servicing, and I'm hoping the maintenance folks are experts. But every now and then it breaks down, and I get frustrated. I get no heat at night. And you hear these type of stories everywhere, right? Like you have, even in nuclear plants, things go down. They had a nuclear leak. They forgot to maintain this or that. It compromises people in 25-mile radius. We had that in 3 Mile Island a few years ago. You know, we're still worried if all those people living near the plant got cancer. No, as they say, stuff happens, right? So it's real hard to optimize some of these maintenance, but it still can be done by breaking down those problems into smaller components and optimizing each one for continuous improvement. So I'm happy to say, obviously 15, 20 years ago, my boiler used to go down at least once a year. Now I'm on, knock on wood, 3 years and my boiler has not gone down. So somewhere along the line in that maintenance circle, the company that I used and the boiler manufacturer that I used must have improved, right? Must have done some improvements. And that's why, as a consumer, I'm seeing benefit, right? I'm seeing nothing. I've not had a heatless day in 3 years, which before was not a possibility. It used to break down at least once a year, right? At least, no matter how well I maintained it. So I'm not an expert in boilers. That's just a consumer standpoint. It's an example that I gave you, but certainly the company that supports my boiler and supports my maintenance contract has definitely done a good job in providing continuous improvement even in the maintenance process. So that concludes my thoughts and comments on quality improvement. I'm going to pause here and take questions, and I'll stop the recording.